Good afternoon, everyone. Welcome to I Square Maths Academy, where numbers and variables actually meet mastery. In our last class, we actually looked at integration by parts, and we solved this question, taking the value of u, taking the value of u to be equal to e raised to the power of 2x, and the v equal to cos 2x dx. Now, in this class, I want us to take u to be equal to cos 2x and the value of the v to be equal to e raised to the power of 2x. So here, let u be equal to cos 2x and the v be equal to e raised to the power of 2x, and here we have dx. Yes. Now remember, integral u to v is equal to uv minus integral v du. Yes, integral u to v is equal to uv minus integral v du. So now we have the value of our u to be equal to cos 2x and the v is equal to e raised to the power of 2x dx. Now, let's get the value of the u. Now, if u is equal to cos 2x, it means the u all over the x will be equal to, when you differentiate this, remember in our class on differentiation, we said when you have a function like this, what you need to do is just to differentiate the whole of this, and that will give you minus sine 2x, then you multiply it by the derivative of the function. Now this is the function 2x. So when you differentiate 2x, it gives you 2. So it means the whole of this now will be equal to 2 times minus sine 2x. That will give us minus 2 sine 2x. Now that's the value of the u all over the x. Now if the u all over the x is equal to minus 2 sine 2x. Now, it means that the u will be equal to minus 2 sine 2x. Then here we have the x. Now, let's take note of this now. Yes, this is the value of the u. Yes, the u is equal to minus 2 sine 2x dx. Now, let's come back to this. Now, the v is equal to e raised to the power of 2x dx. Now that we have the value of our v, the v, to be equal to e raised to the power of 2x dx, now our v will be the integral of the v. Now it means we are integrating e raised to the power of 2x. So here we have e raised to the power of 2x dx. And when you integrate e power 2x, it gives e raised to the power of 2x. Yes, e raised to the power of 2x times. Now, remember in the case of differentiation, yes, of function, we said you are to differentiate this, then you multiply it by the derivative of the function. Now, when it comes to integration of function, you are to integrate, and when you integrate e power 2x, it gives e power 2x, then you times it by 1 all over the derivative of the function. And the derivative of this function here, 2x, is 2. So it means that will give us 1 all over 2 e raised to the power of 2x. Now, that's the value of our v. Now, let's take note of this as well. Yes. Now, we have actually seen the value of the u and also the value of v. And remember, we said integral u to v is equal to uv minus integral v to u. Yes, integral u to v is equal to uv minus integral v to u. So it therefore means that integral u, the value of our u now is cos 2x. So here we said e power, let's put it here first. We have cos 2x as the value of our u, then our the v here is e raised to the power of 2x. Then we have the x. Now this will be equal to, you pick the value of u. The value of u is cos 2x. So here we have cos 2x. Then now the value of v. The value of our v is 1 all over 2 e raised to the power of 2x. Then here we have minus. Look at the minus here. Then we have integral. The value of v. The value of v is half e raised to the power of 2x. Yes, half e raised to the power of 2x. Then here we have du. Now the value of our du is minus 2 sine 2x. So here we have minus 2 sine 2x. It therefore means that integral cos 2x, here we have e raised to the power of 2x, the x will be equal to, here we have this. So this will give us 1 all over 2 e raised to the power of 2x cos 2x minus. Now looking at this, those 2 here will go with this 2. Okay, so we have minus. So minus will automatically change this to plus. So here we have plus. Then we have integral e raised to the power of 2x. Then here we have sine 2x. Yes, sine 2x. Then we have the x. Okay, sine 2x, the x. Okay, now in this case, here we have the x. Yes, we have the x because here we have the u. And the u is minus 2 sine 2x, the x. So that is the x. So now, this is another product function. Yes, where we have e raised to the power of 2x and we have sine 2x. So this is the product of two functions. So it therefore implies that we are still going to repeat the integration by parts here. Yes, to analyze this, we are still going to repeat the integration by parts. Now, in this case, let u be equal to sine 2x. Sine 2x, and the v be equal to e raised to the power of 2x, the x. Yes. Now, if u is equal to sine 2x, the u all over the x, when you differentiate sine 2x, it gives cos 2x. Then you multiply it by the derivative of this function. The function is 2x. That will be 2. So it means here we have 2 cos 2x. So it therefore means that du all over the x is equal to 2 cos 2x. Yes, that's the value of our du all over the x. Du, the x is 2 cos 2x. So it means that here, the value of our du will be equal to, when you cross multiply, because this is the same as saying over 1. The u times 1 is the u, and 2 cos x times the x. Now give us 2 cos 2x dx. Now let's take note of this again. Yes, this is the value of our du. Now, we said let the v be equal to this. So it means our v now is equal to e raised to the power of 2x. Then here we have dx. That's the v. Now to get the value of our v will be the integral the v. Now remember, we said integration is the reverse aspect of differentiation. So it means since the derivative of v is equal to this, now to get the reverse aspect, we have to integrate it. And that's the reason why we are integrating the v to give the value of v. Now when you integrate e raised to the power of 2x, it gives e raised to the power of 2x all over 2, all over 2. Yes, that is, you integrate this and multiply it by the derivative, 1 all over the derivative of this function. That is exactly what we did here. Now let's also take note of this. Yes, let's take note of this. That v is equal to integral dv, and it's equal to e raised to the power of 2x all over 2. Now, integral cos 2x. Cos 2x e raised to the power of 2x dx, which is also the same thing as saying integral e power 2x cos 2x dx will be equal to uv. Now we are still making use of this. Yes, we are still using this. Yes, that integral u dv is equal to uv minus integral v du. So in this case, now we're going to pick our u, and we say let u be equal to sine x. So but before this, we have a function here that is 1 all over 2 e raised to the power of 2x. Here we have cos 2x. Then here we have plus. Now we are bringing in the whole of this now. That's the integral of this using the same integration by parts. So it means here we have uv. Our u is sine 2x. So we have sine 2x. Then now the value of v. The value of v. Now remember, we actually integrate the v, and we got e raised to the power of 2x all over 2 as the value of v. So here we put it there. E power 2x all over 2. Yes. Minus integral. Yes. Minus integral v du. Now our v is e power 2x all over 2. So here we have e power 2x all over 2. Then we have the u. And the u is 2x, 2 cos 2x. Now let me drop it down here. So here we have minus integral. Yes, we have v e raised to the power of 2x all over 2. Yes, that is for v. Then now the value of the u. Our du is 2 cos 2x. So here we have 2 cos 2x. Then close the brackets. So it means in this case, integral cos 2x, or since we'll start with this, so we have e power 2x cos 2x dx will be equal to, so here we have 1 all over 2 e raised to the power of 2x cos 2x plus, so here now this is a constant, so I can bring this out. So we have 1 all over 2 sine, 1 all over 2 sine sine 2x, then e raised to the power of 2x, 1 all over 2 sine 2x e raised to the power of 2x, plus minus is minus. Then here we have this 2 will go with this 2. So we'll be left with integral e raised to the power of 2x. Then here we have cos 2x plus c1. Okay, now let A, we can use any of the variables. Let A, but since we use I in the first one, let's use I. So let I be equal to integral e raised to the power of 2x cos 2x dx. Yes, let I be equal to this. And this is actually the original question. Yes, because we have to integrate e raised to the power of 2x cos 2x dx. So now we are saying let I be equal to this. So it therefore means that the whole of this now will be I. So here we have I will be equal to, here we have 1 all over 2 e raised to the power of 2x. Now, if you look at these two functions, you will discover that 1 all over 2 is common because we have it here and we also have it here. E power 2x is also common. We have e power 2x here and we also have it here. So it means here we'll be left with cos 2x plus, here we have sine 2x, then minus. Now remember we said let I be equal to this. So it means this is I. So here we have I plus C. So it means in this case, I want to collect like terms. Now collecting like terms, collecting the I. So here we have I. When you bring this minus I to the left hand side, it becomes plus I. And that will be equal to 1 all over 2 e raised to the power of 2x in brackets. Here we have cos 2x plus sine 2x. Then here we have plus C. Okay, so in this case now, I plus I is equal to 2i. Yes, I plus I is equal to 2i. So it therefore means that the value of our 2i will be equal to, yes, that is I plus I. 2i will be equal to 1 all over 2 e raised to the power of 2x, e power 2x in brackets. Then we have cos 2x, cos 2x plus, then here we have sine 2x. Okay, sine 2x. Now let me put C1 here. Just let me C1. That's partial constant. Okay, C1. So it means in this case, I'll put my C1 here. So now let's divide through. Yes, let's divide via by the coefficient of I. Yes, by 2. Yes, because here the coefficient of I is 2. So it means here we have 2i all over 2 is equal to half e raised to the power of 2x. Here we have cos 2x plus sine 2x all over 2. Okay, now let's go C1 over 2. So it means in this case, this 2 will go with this 2. I'll be left with I. So I now will be equal to half divided by 2. That will be 1 all over 4. Then we have e raised to the power of 2x in bracket cos 2x plus sine 2x. Now, since this is constant, so C1 all over 2 now is the same thing as T constant. So here we call it big C. So this is the integral of this. So remember the value of our I. We said let I represent integral e raised to the power of 2x cos 2x dx. So it therefore means that integral e raised to the power of 2x cos 2x dx is equal to 1 all over 4 e raised to the power of 2x in bracket cos 2x plus sine 2x, then we have plus c. So this is the integral of this function. So that's all about this. So thank you so much for listening, and watch out for more examples under this integration by part. Thank you so much.